Hello students, we'll move on with the next problem related to Banker's algorithm. So in the previous videos, I have explained you about Banker's algorithm and also solved one problem associated with it. So what's the difference between this and the previous problem is, in the previous problem, they have given you the value of available. So, but in this case, they have not given us the value of available, but they have given us some additional information. What is that additional information? We'll just see. So, in the question, they have told us there are 5 jobs, J1 to J5, and there are 3 resources, R1, R2, R3. So, each of the resource type R1 has 10 instances, or you can say 10 copies. R2 has 5, R3 has 7. So this is the additional information which is given to us. So using this information, we have to calculate the available value. Okay. So how to calculate, I will tell you. So to do this, you require the allocation and maximum value will be given to you. Using this value of allocation, we are going to calculate the value of available. Okay. How to do it, we'll see. So here you have to add. Okay. So here resource R1. Okay, so for different jobs J1, J2, J3, so for J1 resource type R1 0 instance is allocated. Maximum J1 requires 7 instances of resource R1, but as of now nothing is allocated, so it is 0. For J2 maximum 3 is required, but as of now 2 is allocated. Okay, so that is what it tells. So to calculate the available, what you have to do here is you have to add all this. Okay, so resource type we have to add allocation. Okay, so you add all this. So 5, 6, 7. So 7. Similarly, this is 2 and this is 4. Okay, so what is the meaning of this? Resource type R1, in the question they have told 10 instances are there. Out of that 10, how much is allocated? R1, how much is allocated? 7. So how many will be remaining? That is 10 minus 7. So available is 3. Similarly for R2, total how many are allocated? 2 are allocated. How many are there? 5 are there. So 5 minus 2, that is 3 are available right now. Similarly R3, 4 are allocated, 7 are there. Total 7 are there. Out of that 4 is allocated. So 7 minus 4, that is 3. So this is how you have to calculate the value of available. Okay, I hope you have understood. So in case available is not given, they will give you this information. Using this, you have to calculate the available value. So how we are going to calculate? Total how many are there, out of that how many is allocated, the difference of that will give you available. Okay, so this is how you have to calculate the value of available. And in some cases, just to confuse you, what they do, they give you the value of available, along with that they give you this information also. So in such cases, don't get confused, this is not required. You are using the available value what they have given. In this problem it was not given, so we have calculated. If they have given you the value of available, just see that. Okay, so this is the one thing. Next in the question, find the need matrix. So how we are going to calculate the need matrix? So formula we have already seen in the previous video. So the formula to calculate the need matrix is max minus allocation. So maximum value is already given to you in your question. So for each job you have to see. So for job J1, resource type R1, maximum 7 is required. How much is allocated? 0 is allocated. So 7 minus 0 will give you need. The meaning of that is, for job J1, resource type R1, how much it requires? It requires 7. That is nothing but need. Similarly for J1 and resource type R2, max it requires 5. Out of that 1 is allocated. So 5 minus 1 is 4. Similarly 3 minus 0, that is 3. 3 minus 2, 3 minus 2 is 1. 2, 2, 6, 0, 1. 2 minus 2 is 0, 2 minus 1 is 1, 2 minus 1, 1. Similarly 4, 3, 1. This is how you are going to calculate the need matrix. So if you have done this much in the external exam, 2 marks will be allotted to this. Okay. So next we'll come to the next part, that is you're checking whether the system is in safe state or not. So what do you mean by a system is in safe state? If all the processes are able to execute, then you're saying that system is in safe state. So when you can say job is completed its execution, job is asking for some resource. If that resource can be given to the job and job is completing its task, then you're saying if all the jobs are completed, then you're saying system is in safe state. That time you have to give a safety sequence. So how to do that we'll see. So as told in the previous video, so to calculate whether the system is in safe state or not, you require to use the safety algorithm. So according to the safety algorithm, what is the first step saying? You have to initialize available to work. So according to that, what you're doing? So you're initializing the value of available to work. Okay, so available value you have already calculated. So what is the value of work? That is 333. Okay, so value of work is 333. Next, what you're going to do, you have to check for all the jobs. So you have job J1 to J5. So for all the jobs you have to check. What is the checking you have to do? So first of all you have to make, so for job J1 we will start. For J1, first of all you have to make finish of J1 as false. Okay, because initially we don't know whether that can be executed or not, so initially we will make it as false. Next step is need of J1, you're checking whether it is less than work. Okay, so need of J1 you're going to get in the need matrix, that is 7 4 3, less than or equal to work. So work we have assigned as 333. Okay, so this is false, right? So 7 is not less than 3, so it remains false, so this remains false only. So in that case go to the next job, that is J2. First thing is make finish of J2 as false. After that you're checking need of J2 whether it is less than work. So need you're going to get in the need matrix, need is 1 2 2, whether it is less than 3 3 3. Yes, it is true. When it is true, what you're going to the next step. There what you're doing, work is equal to work plus allocation. So what you're going to do, you are going to update the value of work. So work is equal to previous work. What is the previous work? That is 333 plus allocation. Allocation of which process? Of which job? That is J2. So allocation of J2 is given in the question, that is 200. So the new value of work you're going to get is 533. This is a new value of work what you're going to get. Then after that you have to make finish of I equal to true. That is nothing but the meaning of this is this particular process has been executed or completed. So that time what you're going to do, you're making finish of J2 equal to true. So whenever any process finish of that particular process becomes true, somewhere in the corner you write the safety sequence. So according to that, first process to be executed is J2. Now go to the next one. We'll just continue here. We'll go to the next one. Okay, what is the next process? That is J3. Check for J3. So anyways, finish of J3, initially we will make it as false. Then you're checking need of J3 whether it is less than work. So the new work value you got as 533. New work value is 533 and need of J3 is 601. 601. So this is false because 6 is not less than 5. So you cannot go ahead with it. Go to the next job then. Next job is J4. So first make finish of J4 as false. Then you check need of J4 whether it is less than work. So work is 533. Need of J4 is 011. Yes, 011. 0 is less than 5, 1 is less than 3, 1 is, yes, this is true. That time what you're going to do, you're going to update the value of work. Work is equal to work, that is 533 plus allocation of J4. Allocation of J4 you're going to get in the question, that is 211. So the new value of work is 744. Okay, after that you have to make finish of J4 as true. So whenever it becomes true, update here. So the next process to complete is J4. Next go to the next one, which is the next process, that is J5. Initially you make finish of J5 as false. Then you check whether need of J5 is less than or equal to work. Now your new work is 744. Need of J5 is 431. 431 is less than or equal to 744. 4 is less, yes, this is true. That time what you're going to do, work is equal to work, that is 744 plus allocation of J5. Allocation of J5, check the question, that is 002. So the new work you got is 746, and after that you have to make finish of J5 as true. So update here. Next process is J5. So you are done with J2, J4, J5. So J5 is the last process, but you still have some process which is not yet completed. So from here again you have to come to the first process. So now you have to check for J1. Check for J1. So initially you make finish of J1 as false. Then you are checking whether need of J1 less than or equal to work. So what is our last work value got? 746. 746. Need of J1 is 743. 743 is less than or equal to 746. Yes, it is true. Then what you're doing? 7 is less than 7. 4 is yes. 3 is less than yes. So work is equal to work, that is 746 plus allocation of J1. Allocation of J1 is 010. 010. So the new work value you're getting is 756. 756, yes. And after that you have to make finish of J1 as true. Whenever it becomes true, update here. So the next process is J1. So which is left out now? J3 is left out, right? J1, J2, yes, J3 is left out. Now you have to check for J3. You have to come in the order. So after J1, next J2 is already completed. So again you need not check for J2. For which process finish of that value is false, only for that process you have to check. Okay. So after J1 we are going to J3 because J2 is already executed. So go to J3, finish of J3, initial it is false, need of J3 is less than or equal to work. So your new work value is 756. Need of J3 601. So you're checking 601 is less than or equal to 756. 6 is less, yes, 0 less, yes. This is true. Then what you're doing, work is equal to work plus allocation of J3. Allocation of J3 is 301. 301. So the work value you're getting is 10, 5, 7. Okay. So the final available, we said right, work is nothing but available. So final available value you're getting is 10, 5, 7. Okay. After that finish of J3 you're making it true. When you're making it true, you write it in the safety sequence. Okay. So now what happened? Therefore, since you're trying to conclusion, since finish of I, that is for all I is equal to 1, 2, 3, 4, 5 is true. Therefore, the system is in safe state, and the safety, this is very important, safety sequence you have to write. Okay. So it is written within the angular bracket. So whatever you had written in the corner there, so you write that J2, J4, J5, J1 and J3. So this is a safety sequence. This is very, very important. So what is the meaning of this? If the processes are executed or jobs are executed in this order, then your system is in safe state. Safe state means all the jobs can be executed or process can be executed. Okay. So this is you're checking whether the system is in safe state or not by using the first algorithm of Banker's algorithm, that is safety algorithm. One more thing here. So you got 10, 5, 7 at the end. Just for verification purpose whether this is correct, you can compare it. So what they said here, R1 has 10 instance. So did you get 10 here? The first one is R1, right? R1, R2, R3. So R2 has 5 instance, R3 has 7 instance. So you got the same value. Okay. So therefore your answer is correct there. So this is how you have to solve. Okay. Thank you.